Here's an example of the total rate of change formula. It's to do with pressure of a gas, but let's just write down what the total rate of change formula is when we've got pressure, volume and temperature and changing over time. So we've got dP dt is approximately equal to the partial derivative of pressure with respect to volume times dV dt plus the partial derivative of the pressure with respect to temperature times the derivative of temperature with respect to time. So this is saying that the total rate of change of pressure over time can be calculated approximately by this formula. All right, what have we got? We've got P as a function of V and T. So we'll be able to calculate that. We'll be able to calculate that. dV dt. dV dt is the rate of change of volume over time. And we're actually given that the rate of change of volume is 0.04 litres per minute. So we've got dV dt is equal to 0.04. And we also know that the rate of change of temperature. So we know that the capital T for temperature over little t, which is time, is equal to 3. So we've got that, we can calculate that, those two partial derivatives, because we've got P as a function of volume and temperature. So therefore we'll be able to find dP dt. All right, let's do the first one. So we've got the partial derivative of pressure with respect to volume equals partial derivative with respect to volume of the P function, which is 10V over T. Now, if we're doing with respect to V, then T is constant. So 10 over T, if you like, can come out because both of those are constants. And the derivative with respect to V of V is just 1, so that'll be just equal to 10 on T. The partial derivative of the pressure with respect to temperature now what's constant here? The V. So 10V will be constant, it can come out the front. So 10V are constant, so the partial derivative with respect to temperature. Now instead of writing 1 over T, it's probably better to write as T to the minus 1, because that makes it easy to apply the rule. And the rule is this 10V is a constant, so 10V and then times, now the derivative of this, you multiply the coefficient, which is 1, so 1 times negative 1, so that'll be negative 1 times T, and then you take 1 off the power, minus 2. So that'll be negative 10V all over T squared. To the negative 2 can be downstairs with the positive 2. The negative comes out the front and the 10V goes to the top. Okay, now I think it's time to substitute into dP dt, so the rate of change of the pressure over time. We've got this. So partial derivative will be 10 over T. What is dV dt? dV dt times 0.04 plus partial with respect to time was equal to negative 10V over T squared. And what is dt dt equal to? Change of temperature over time will be equal to 3. That's times 3. We can knock this into better shape. 10 times that will be 0.4 over T. Plus or minus is the same as just subtracting. 3 times 10 will be 30V over T squared. So that will allow us to work out approximately what the rate of change of pressure over time, given a temperature, given a volume, when the change in volume and change in temperature are given. So you can actually substitute, if you're given T and V, you can actually find the approximate change in pressure.